Precalc students, in this video for lesson 7.3, we're going to look at solving a system of equations using inverse matrices. So we've looked at row echelon form, we've looked at using our calculators to find reduced row echelon form, both great ways for solving a system of equations. Another option you've got with matrices is to use the idea of inverse matrices. So in the box here kind of outlines the process. Step one would be to write the system as a matrix equation where I've got matrix A times matrix X is equal to matrix B. So matrix A is going to be the coefficient matrix, X is the matrix of variables, and B is the matrix of constants. And I'll show you how this might look over here using this double system. So I got two equations, two variables. I'm going to set up a system of equations for this, or a system of matrices for this. So my coefficient matrix, matrix A, will be a 2 by 2 matrix because I've got two equations and two variables. So in this matrix, I'm going to put my coefficients 3 and -2 and -1 and +1. Okay? Matrix, that's matrix A. Matrix X is going to be this unknown matrix that I'm going to multiply by. Now what I'm going to do is matrix X is going to be equal to the variables. Okay? And I'm going to have the variables stacked in a single column. So I have to have a 2 by 1 matrix. Now, if you think about matrix multiplication, hopefully this makes sense because I have to have the number of columns in one equal to the number of rows in the next one. So the inner dimensions got to be the same. So 2 by 2 times 2 by 1 is going to work out. Okay. What's going to happen then too is if you multiply these, remember you take a row times a column. So you'd be taking 3 times x plus -2 times y. Well, 3 times x plus -2 times y is 3x minus 2y. Okay, and then -1 times x plus 1 times y is -x plus y. That's what we got down here. Now that's equal to another matrix. Now when you multiply 2 by 2 times 2 by 1, you're going to end up with 2 by 1. So hopefully that matrix multiplication makes sense. And over here in this matrix, this is matrix B. We're going to put the constants that we got on the other side of each equation. So it's 0 and a 5. Okay. So step 2, find the inverse of matrix A. Okay. Which if you do this, you can find the inverse. Find the determinant and then switch these and switch the sides of these. Do that by hand. I wouldn't do it by hand though, because if you're going to solve this with a calculator, do the whole thing on the calculator. Is kind of the idea. Okay. So we're going to skip right to step 3 because we're assuming we can find an inverse. Okay. So we're going to then multiply each side of this equation by the inverse of A on the left. Now, this is important stuff here. Way to think about this is if I were to solve this equation, AX equals B. Okay, A times X equals B. Well, you could say to yourself, well, I'm going to divide by A. Okay, right? When that makes sense algebraically to divide both sides by A. Hey, that's neat. But matrix division isn't something that we're allowed to do. You don't divide matrices. Okay, so if we have to keep it to multiplication, instead of dividing, I'm going to multiply by the inverse. Okay, if you think about like fractions, instead of dividing, you multiply by the reciprocal. The inverse is kind of like the reciprocal of the matrix in a way. So I'm going to multiply by the inverse. So I'm going to multiply this by A inverse. Okay, I'm doing both sides. So A inverse times A. Well, when you take a matrix times its inverse, you end up with the identity matrix. Okay, and the identity matrix is like the 1 of the matrix world. So 1, or the identity matrix, times x, who cares? That's not going to matter because the identity property of multiplication says if I take the identity matrix, or 1, times another matrix, I'm going to get the original matrix. So that's going to equal just x. Now, if I do something on one side, I got to do the same thing on the other side. Now the key is we're going to multiply on the left. Okay, it's got to be equal to A inverse times B. And that's on purpose because if you were to try and go the other way, if you were to try and take B times A inverse, your dimensions wouldn't match up. Because matrix B, if you remember, is 2 by 1. And matrix A inverse, it's a square matrix and A inverse is going to be a square. You're going to be multiplying by a 2 by 2 matrix. And now the inner dimensions don't match. This is an undefined product. Can't happen. So the order is very, very, very important. Okay. The neat thing is that when I'm done with this, x which is this coefficient matrix, is going to equal whatever I get when I take A inverse times B. Okay. And I'm going to get, if I do that correctly, it'll be 2 by 2 times 2 by 1, and my result is going to be another 2 by 1 matrix. So hopefully that makes sense algebraically to you. Let me show you how it works in the calculator. So I would Opening up my calculator. Enter these matrices. So I've already got them put in. If I go to my matrix menu, I've got matrix A. I edit matrix A. I need a 2 by 2 matrix. This is for the coefficients. So 3, -2, -1, 1. Then I'm going to edit a second matrix, matrix B. And I need a 2 by 1. That's the 0 and the 5 from over here. Once I got those in, I go back out to my home screen. And I am going to multiply A inverse times B. So A inverse times B. Again, that's the steps. Again, if I know what I'm doing, I know how to set it up. A inverse times B is what's going to give me an answer. Notice it gives me a stacked, hey, 2 by 1. Remember, if it's 10 and 15, if you're thinking about what this means for us, it means that matrix X, which was matrix X was X and then Y stacked on top of each other. That means for this system that X must be 10 and Y must be 15. Okay, so that would be the solution to this system of equations. Now you can do REF like reducer echelon form and still get 10 or 15. You could do this by hand with substitution, elimination. You could graph it, whatever. This is just another tool in your toolbox when it comes to solving systems of equations. Now we'll do the same thing with a 3 variable 3 equation system. Okay, so similar process. I need matrix A and matrix B. Okay. So matrix A, I'm going to turn my coefficients into a matrix, excuse me, and then matrix B would be these, okay? And I'm going to take the inverse of this, so I'm going to, X, which will be X, Y, Z stacked on top of each other, is going to equal A inverse times B, okay? Now, because I did this ahead of time, I put these matrices in as matrix C and matrix D, so notice 3 by 3 and 3 by 1. Matrix C was my coefficient matrix, okay? And matrix D was my constant matrix, 20, 40, 30. So it makes a difference because I'm not going to do A inverse times B. I'm going to do my calculator C inverse times D. Okay, a 3 by 3 times a 3 by 1. I hit enter. I get this. So 18, 39 and a third, and 14. Okay. And if you want to change that to fractions because you're unsure about what 0.333 is, it's 1/3. So 39 and 1/3 or 118 thirds, 18. So that'd be my order triple. Okay. Let me drag that out of there. Oops. So there would be my answer to that one. Okay. So that's the order triple that satisfies this triple system. So again, is RREF or reducer echelon form easier? Maybe. Just total personal preference. If you want to use inverse matrices, this is a great way to do it. If you want to use reducer or echelon form, it's also a great way to do it. They both work. They're both using your calculator and applying what you know about matrices to solving systems.